Welcome to Getting Started with the Python Console. If you're just beginning your Python journey, the console is the very first tool you'll fall in love with. It's a live, interactive environment where you can type Python code and see results instantly. In this video, we'll walk through everything you need to know, from opening the console to writing professional-grade logs for your programs. So, what exactly is the Python console? It's also called the interactive shell, or REPL, which stands for Read Eval Print Loop. Here's what that means in practice. You type a line of code, Python reads it, evaluates it, prints the result, and then loops back to ask for the next line. Think of it as a live conversation with Python. You can test a quick idea without writing a full program, check what a function returns, debug a piece of code in isolation, or simply use Python as a powerful calculator. It's instant, interactive, and perfect for learning. Opening the console is dead simple. On Windows, open Command Prompt and type Python. On macOS or Linux, open Terminal and type Python 3. Hit Enter, and you'll see the Python version information followed by 3 greater than symbols. That's Python's way of saying, I'm ready. What do you want me to do? Notice how on Windows you just type Python, but on macOS and Linux you need Python 3, because the system might have Python 2 installed as well. Once you see those triple chevrons, you're in. Let's try our first commands. Type print, open parentheses, quote, hello world, close quote, close parentheses. Hit Enter, and there it is, hello world. The print function displays whatever you put inside its parentheses. Now watch this. Type 5 plus 3 and hit Enter. Python immediately returns 8. No print function needed. For simple expressions, the console shows the result automatically. Try 10 times 4, that's 40. Or 100 divided by 6, you get 16.66 repeating. This automatic evaluation is one of the things that makes the console so great for quick calculations and testing. Now let's work with variables. Type name equals quote, Alex quote. Then age equals 22. These values are now stored in memory, and you can use them across multiple lines. Watch the memory model on the right. You can see the variable name pointing to the string object, Alex, and age pointing to the integer 22. Now, here's where it gets really powerful. F strings. Type print F quote. Hi, I am, open brace name, close brace, age, open brace age, close brace. The F before the string lets you embed variables directly using curly braces. Python replaces each brace with the actual value. It's super handy, precious age. Python replaces each brace with the actual value. It's super handy, and you'll use it all the time. Want to make your programs interactive? Use the input function. Type city equals input. Quote, what city are you from? Quote. Python will pause and wait for you to type something. Let's say you type Dhaka. That text is now stored in the variable city. Then type print F quote, nice, exclamation. Open brace city, close brace, is great, quote. And there it is, nice, Dhaka is great. The input function always returns a string, so if you need a number, you'll need to wrap it with int or float. For example, age equals int of input. This is how you build programs that actually talk to the user. After running a bunch of commands, your console can get pretty cluttered. Python doesn't have a built-in clear command, but you can create one yourself. First, import the OS module. Then define a Lambda function called clear that calls os.system with clear on Windows or clear on macOS and Linux. The expression OS name equals ntchecks if you're on Windows. Now, whenever you call clear, your screen wipes clean. It's a simple trick, but it makes the console much more pleasant to work with, especially when you've been testing a lot of code. One of the best uses of the Python console is debugging. Say you have a list of scores and you want to check what's inside it, step by step. First, Create the list. Scores equals bracket 85, 92, 78, 90, close bracket. Print it to see the full list. Now, use the max function to find the highest score, that's 92, and calculate the average by dividing the sum of scores by the length of scores, that gives us 86.25. Watch how each operation appears in the terminal output on the right, and how the data structure visualizer on the left shows our list. Testing each piece of logic individually before putting it into a script saves a ton of time when something breaks. As your programs grow, using print for everything starts to get messy. That's where logging comes in. The logging module is Python's built-in tool for recording what's happening inside your program, like a diary your code writes for itself. Look at the comparison table. Print can show output, but that's about it. Logging can do all of that, plus write to files, track severity levels, be easily turned off, and is production ready. Logging has 5 severity levels from least to most severe. Douglas died for detailed diagnostic info. Info for confirmation that things work. Warning for unexpected events. Error for failures. And critical for serious problems that might stop the program. Let's set up basic logging. Import the logging module, then call basic config with level set to logging skilled. This means we'll see all messages from debug and above. Now, watch as each log level produces a labeled message. Debug gives us checking values. Info says, program started. Warning alerts us about low disk space. Error reports could not read file. And critical warns of system failure. Each line is automatically prefixed with its severity level, so you always know exactly how serious each message is. This is the simplest way to start logging, and it works great for small scripts and quick projects. Timestamps make logs much more useful, especially when you're trying to figure out when something went wrong. Add a format parameter to basic config with 3 codes. AskTime for the timestamp, level name for the severity, and message for your text. Now look at the output. Each log entry shows the exact date and time it was created, followed by its level and message. Server started at 10:42:01, and the slow response warning happened at the same second. These format codes, AskTime, level name, and message, are the most commonly used ones. With timestamps, you can reconstruct exactly what happened and when, which is invaluable when debugging production issues. For real applications, you'll want to save logs to a file so you can review them later. Add file name equals myeptpa.log to your basic config. Now, all your log messages go to that file instead of just the screen. The file mode parameter controls how the file is handled. W overwrites the file each run, while A appends to the existing file, which is usually what you want in production. Watch the file write animation on the right. As each log message is generated, it's written to the myep.log file. This way, even if your program crashes, you still have a complete record of what happened leading up to the failure. When your project grows into multiple files, you'll want separate loggers for each part. Create a named logger with getLogger. Set its level to die_bid. Then, create 2 handlers, a stream handler for the console set to info and above, and a file handler for the error log set to error and above. Attach a formatter to both handlers so your messages look consistent. Now, when you log an info message like shows in console, it only appears on screen. But when you log an error like goes to both, it appears on screen and gets saved to the errors.log file. This gives you fine-grained control over where different types of messages go, which is essential for larger applications. When your code crashes, logging can capture the full error details, not just that something went wrong, but exactly what and where. Inside an except block, use logging.exception instead of logging.error. Watch what happens. We try to divide 10 by 0, which raises a 0 division error. The accept block catches it and calls logging.exception with a message. The output shows not only the error message, divide by 0, but also the complete traceback, which file, which line, and exactly what went wrong. This is extremely useful for debugging crashes in production because you get the full context of the error, not just a vague message. Congratulations! You've mastered the Python console and logging. You learned how to open the console, run your first commands, work with variables and f-strings, get user input, clear your screen, debug step by step, and set up professional logging with timestamps, file output, custom loggers, and exception handling. Now that you're comfortable with the console, a great next step is learning about functions and modules, the building blocks that make your Python programs organized and reusable. Thanks for watching, and happy coding!